So we're going to be solving trig equations here. Again, before we start anything, we need to go back to this one. All students take calculus. That's the saying a lot of people use. The truth is not all students take calculus. So if you want to change it to something else, you can. You can write all stores take cash. What's the big deal about this? Let's talk about the first three trig functions, sine, cosine, and tangent. What this chart tells you, who is positive in which quadrant? This one in the first quadrant, that's quadrant 1, that's quadrant 2, that's quadrant 3, and that's quadrant 4. 1, 2, 3, 4. In the first quadrant, regardless which one we use, who is positive? All three of them. Sine is positive, cosine is positive, tangent positive. I don't know why I'm writing this twice, but you can use all students take calc or all stores take cash. Doesn't really matter. In the second quadrant, out of these three, which one begins with the letter S? Student begins with the letter S. Out of these three, which one begins with the letter S? The sine. Only the sine is positive. Cosine is negative. Tangent is negative. Sine, cosine, tangent. Now in the third quadrant, take. The word take begins with the letter T. Only the tangent is positive and the other two are negative. And in the fourth quadrant, cash or calculus there, both begins with the letter what? C. So the cosine is positive, the other two are negative. Now, if you want to expand that to secant, cosecant, cotangent, go ahead. Positive, positive, positive. Secant, cosecant, cotangent. Now secant is 1 over what? Cosine. Since the cosine is negative, 1 over negative number is negative. Cosecant is 1 over the sine. Since the sine is positive, this is positive. And cotangent is 1 over the tangent. If the tangent is negative, this is negative. Secant, cosecant, cotangent. Let's look right here. Since the tangent is positive, 1 over a positive, that's a positive. These two are negative. And in the fourth quadrant, secant, cosecant, cotangent. Cosine is positive, that means secant is 1 over the cosine. 1 over a positive, that's a positive. These two are negative. So that's how you know who is positive in which quadrant. Now, why is that important? What's the big deal about this? Well, this section is solving trig equations. So let me give you a trig equation, and I'll wait till you finish writing. Everyone's journey done? Okay. Let's take this one. 2 sine x minus 1 is equal to 0. And the question, solve for x. Two times sine of x minus 1 equals to 0. That's an equation. Let's solve it. Let me take the minus 1 to the right side. When I change side, I change sign. 2 sine of x equals 1. Because you're adding 1 to both sides. But instead of adding 1, I use change side, change sign. Only when you have addition subtractions, you can do that. Change side, change sign. 2 times sine of x. So to solve for sine of x, you divide by 2. Sine of x equals what? 1/2. Can I find x? I did print 40 copies of unit circle. I don't know what I put up. Let me give each one of you a copy. So let's take that unit circle. So here's my unit circle. Let's put it there. Now, I said all students take calculus, all stores take cash. That tells me if the sign is positive, it could be where? It could be in this quadrant or in this quadrant. There's two answers. So it tells me where to look for it. So let's look right here. Sine of x equals 1/2. Sine is the second number. What is x equal to from the unit circle? Is it pi over 6? So x must be pi over 6. We also have another one. Has to be 2 of them because it doesn't say anything about quadrant. Has to be 1 in this quadrant. And what's that angle? 5 pi over 6. So we found 2 solutions to that. Let me try another one. Keep the unit circle handy. 2 times cosine, I don't know why I use parentheses here. I'm going to write cosine squared. I don't need the parentheses for it. You know what? I'll flip the papers easier. 2 cosine squared x minus sine of x minus 1 is equal to 0. It says solve, and x is greater than or equal to 0, less than 2 pi. Again, solve for x. Couple of things to pay attention to. Notice this restriction, 0 to 2 pi. That says you have to be in radian. They want the answer in radian. If this is 0 to 360, they want the answer in degrees. So make sure you pay attention to the units here Do they want it in radian or do they want it in degrees? When you have sine, cosine, one problem, that's not a good sign. So we need to change it. I need to convert the sine to cosine or the cosine to sine. If you remember one of the trig identities we had, I'll just write it down. It was sine squared x plus cosine squared x is equal to what? To 1. So if you move the sine squared to that side, you have cosine squared x equals what? 1 minus sine squared x. So if I do that substitution here, if I take the cosine squared, there's the 2 in the front, take the cosine, replace with 1 minus sine squared x minus sine of x minus 1 is equal to 0. Distribute that. 2 minus 2 sine squared x minus sine x minus 1 is equal to 0. Negative 2 sine squared x minus sine of x. What about plus 2 minus 1? What is that equal to? Plus 1, right? And I'll be honest with you, I'm not a fan of starting a problem with a negative. I never like that. There's nothing wrong with it, I just don't like it. So I'm going to multiply everything by negative 1 to switch the signs. I just don't like to start with negative. So that means switch all the signs. Now let's put this problem aside. And let's say I gave you this problem. I said, can you solve this problem? 2y squared plus y minus 1 is equal to 0. How would you solve that? You can factor it, right? Yep. 2y and y minus 1 plus 1. Well, if you look at this problem and look at this one, they're almost the same. Except what? My y is really what? Sine of x. That's what y is. Y is sine of x, y squared is sine squared x. So I should be able to factor this to what? 2 sine x minus 1 times sine of x plus 1. When you're multiplying two things, your answer is 0. The quickest way to solve them, set each one equal to 0 and solve it. That's one of them. This is sine of x equals negative 1. This is 2 sine of x equals 1. Sine of x equals what? 1/2. I just remember. No, that was good. Sine. I thought it was a cosine, that problem. Let's find out where the sine equals 1/2 again. The sine is positive. That means first and second quadrant. Sine is 1/2. Pi over 6 here. We just did that one. And the other one was what? 5 pi over 6. Where's the sine equals negative 1? Negative in this side. The bottom half for the sine. The minus 1, I see it right here. Can you see it? 3 pi over 2. That's it, only one solution. So here's the answers to all of them. What's x equal to? Pi over 6, 5 pi over 6, and 3 pi over 2. These are the three answers that will make this equation go to 0. Let's try another one. Maybe we'll combine this section with the next section, but I'll wait on that. I'm not going to jump into it yet. Let me just take a couple more problems, then I'll come back and combine what we did last class with this class. Both examples so far I did is sine, so let me switch them. Let me maybe do tangent, secant, 4 tangent x minus secant squared x equals to 0. And for some reason, every problem I wrote today, I forgot to write solve. So I have to go back and write solve for x. I'm excited about the problem. I forgot to write solve for x. Again, you always want to have one trig. Meaning what? When I say one trig, you can't use tangent, secant, square. You don't want to use sine, cosine. Either everything tangent, everything secant, everything cosine, everything sine, but only one of the trig functions. You don't want to use tangent and secant squared. That's two trig functions. And again, let's do this x between 0, that's x, and 2 pi. Actually, I'm not going to say equal to 2 pi. When you say equals to 2 pi, that's a 0. You're already using a 0 twice. So it's less than. Here's my trig identity again. Sine squared x plus cosine squared x is equal to what? 1. If you remember, you can divide every one of these by sine, or you can divide every one of these by cosine squared. Let me divide by cosine squared. By cosine squared. What's sine squared over cosine squared? So let me write it down. What's sine over cosine? Tangent. That's tangent squared x. What's cosine squared over cosine squared? 1. What is 1 over cosine? Secant, that's secant squared x. Perfect. Now, I can replace secant squared x with what? Tangent squared x plus 1. Distribute that minus sign. Again, I don't like to begin with the minus. Multiply by a minus 1. And now we're going to solve this. How would I solve this? Again, if I let tangent equals y, this problem will be what? Y squared minus 4y plus 1 is equal to 0. And you want to solve that. Good luck factoring. You can't factor. Now this one. Quadratic formula, absolutely. Minus b plus or minus the square root of b squared minus 4ac divided by what? 2a. That'll be 4. b is minus 4. That's 4 plus or minus negative 4 when you square it, that's 16 minus 4 times 1 times 1. That's 4 divided by 2. 4 plus or minus the square root of 8 over 2. 4 plus or minus, I can break this into 4 and 2, right? And what's the square root of 4? 2. So if I take a 2 out, what's left? 2 plus or minus the square root of 2 over 2.
Why is 16 minus 4 8?
Oh, 12 is it?
Yeah.
Oh. Well, that's what happens when you stay up till 3 o'clock watching the Super Bowl. It becomes a new math. It's all right. I don't mind making mistakes today. My team won. 12, 4 and 3. That's a 3. That's a 3. I was about to give you a warning, like, keep your eyes open. My eyes are shut. I went to bed like 2:30. Got up like at 5 o'clock. Watched the recap on NFL again. Great night. Great night. Okay. You know, people watching the video, just to let you know, we're Tom Brady fan here. Every one of us, hopefully. So since y really equals tangent, so I can say, guess what? Tangent x equals 2 plus or minus the square root of 3. That's what tangent x is equal to. Because all I did, I let y equals tangent x, and I came up with that equation. So I don't have to come back and resolve this one. I know what the solution is going to be. So I got two solutions. Tangent x equals, and my unit circle is not going to help me. It's not going to have 2 plus or minus. So I have to go to my calculator with that one. And where's my calculator here? Somewhere I have a calculator. Here's a cheap one, nothing fancy. What is the square root of 3? Square root on this one, where'd you go? Add to it the 2. So one solution, that's a 2 plus, which will be what? 3.732. And the other one, tangent x, is going to be 2 minus the square root of 3. 0.268. Now, let's talk about the tangent. Where's the tangent positive? Tangent is positive which quadrant? 1 and what? 3. 1 and 3. The calculator is only going to give me one of them. So let me find out where x is. Let's do the inverse tangent. 3.732. Inverse tangent, second tangent. Where'd you go, tangent? Oh, I see it. Almost I don't have it on this one. It's 75 degrees. Oh, actually, the one in radian. Wait, I said in radian. I gotta change mine to radian. I don't know how on this one. Let me try this one. That's in degrees. Degrees.
Go to mode.
On this one, mode. It just says mode.
And then press.
You know what? We can convert to radian in a minute. We'll go back and convert that by hand. I don't know what on this calculator. But if this is one of them, how would I find out the other answer? This is one of them. This is where the 75 is. Where's the other angle? You need to extend the line. When you extend the line, what's that angle from here?
Plus 180.
Add 180 to it. So 75 plus 180. 255. This one here, 0.268, take the inverse tangent, 14.6 degrees, add 180 to it, 194.6. So if you want to find them in radian, here we go. Since I don't have that button here, I'm sure it's here, I just don't know how to use it. Let me look closely, maybe I can find it. No big deal. You multiply by pi divided by 180. So we'll begin with the smallest value, 14.6 times pi divided by 180. 0.255. That's this one. Let's write, I'd like to put them in order there from small to large. Let's take the 75. 75 times pi divided by 180. 1.309. Let's try the 194.6 times pi divided by 180. 3.396. And the last one, 255 times pi divided by 180 equals 4.451. So these are the four answers that if you plug them in here, this should go to 0. Close to, because we're rounding here, will be very close to 0 when you round it. So when you have a tangent, just add 180, or if you're in radian, just add what? Pi. 180 degrees, adding pi to it, if you're in radian. Actually, something to remember, just for you down the road. When you're doing the sign, I'll do them all, summarize them quickly. Just, if you have sine of x, give me a number, positive or negative. Doesn't matter. What is it? 5 can't be. Sine has to be between -1 and 1. So minus 0.268. Notice the sign is negative in the bottom two. The calculator is always going to give you the answer in this quadrant, in quadrant 4. So, and if they said, I'll do degrees because I don't know what the radian on my calculator here. X is bigger than 0, less than 360. I'm switching to degrees. So to find your answers for the sign, I'll try to summarize them on one page. It's going to give me an answer in this quadrant, the calculator. I know that. So here we go. I go x equals the inverse sine of negative 0.268. Negative 0.268, where's the minus sign? Take inverse sine. Notice how it gave me negative 15. First, we have a problem. See how this one is written? They want the answer to be positive, no negative numbers. So how do you convert the negative 15 degrees to positive 15? You add to it what? 360? 344, 345. I left a space there. So that's where the negative 15 is. 345 degrees. What's the other one? For the sine, you want to fold the paper. If you take this paper and fold it along this axis, the y-axis, you will have another angle right there. And how big this angle? What do you think that number is?
180 plus 34.
180 plus the 15, you mean?
Well, if you add that 15, you add that 15.
No, I'm measuring from this line.
Oh, okay.
So what from there, you always measure, this is your reference here.
Yes, 195.
So from here to here, 180, and this opening the same size as that one. So 180 plus 15, 195. So when you're doing a sine, just fold the paper along the y-axis. Cosine, to give the other angle, now I'll take an example. Cosine of x equals, I don't know, plus 0.87. X will be the inverse cosine of 0.87. Here we go. Second cosine, 0.87 second cosine, 29.5 degrees. That's for the sine here. For the cosine, remember the cosine is positive which quadrant? Negative which one? Cosine is positive in 1 and 4, negative in 2 and 3. So for the cosine, what you need to do is fold the paper along the x-axis. Take it and fold it this way. So you'll have another angle down this way. So this is actually 29.5. I should have used 30 to make my life easy. Now what is that angle? Subtract 29.5 from what?
From 180.
About 360. Because if you go all the way here, you travel what? 360. Go back 30 degrees. That's 330.5. So that's the cosine. The cosine, you fold the paper along the x-axis. The sine, you fold the paper along the y-axis. And the tangent, you just extend the line. Negative 4.3. Let's see where the negative 4.3 for the tangent. Uh, 4.3, change sign. Second tangent. Negative. They don't like to use negative. Negative 77 degrees. That's down here. And for a tangent, you always extend the line. So this is the negative 77. We don't want to use negative 77. First, let's find this one. What's this one's going to be? What is it? How'd you get 113, John?
Subtract 77 from 90.
From 180, you mean? Because from here to there is 180.
Right.
Take away
Well, then
77.
I added the number I got from that to 290.
So 90 plus 77.
This opening here
No, 90.
is 77 degrees, the same size as this one.
Right.
So the whole thing from here to there, from here to here is 180. 180 minus the 77 is what? 113? How about 103?
Yeah, well,
That's one of them. I also have another one way down here. And what's that one? That's 360 minus 77. 283?
Yep.
And there's my two answers. Some of these you will not be able to use unit circles, so you have to use your calculator for them. Not every problem is going to be unit circle. Let me try maybe one more. And let me see if I can combine old stuff with the new stuff. What kind of example we're going to use? Okay, I'll do this one. And again, I'll probably stick with degrees just because I'll figure out where that button eventually on my calculator. Here we go. Solve for x. 3.50 sine of t plus 1.2 sine 2t is equal to 0. Before I said you always want to have one trig. Well, you like to, not always. Sometimes you can't. You like to have only one trig function it. Well, I got the sine in both of them. That's good. But I got another problem. This is t and that's 2t. That's another problem. You want to make sure these are matching too. So what do we do here? I can use that trig identity for sine 2t. Sine 2t is 2 times what? Sine t cosine t. There's the 1.2. This is the 3.50 sine t. Two times 1.2, that's 2.4. So 3.50 sine t plus 2.4 sine t cosine t. And there's no way on earth I can change cosine to sine. I kept telling you, you want to have one trig function. Ideally, that's what you want, but I can't get rid of that one. So how would I solve this?
You could add like terms or not.
What do you mean add like terms? I don't have any like terms because these are multiplication. That's one term.
Oh, okay.
Just like having 3.5x plus 2.4xy. We can factor sine t out, right? If you factor sine t, you will have what? You'll have 3.5 plus 2.4 times what? Cosine t. Now you're multiplying two things and your answer is 0. That means one of them has to be 0. So let's take sine of t, set it equal to 0, and we'll look and see what values. And the other one, 3.5 plus 2.4 cosine t is equal to 0. Move the 3.5 to that side. That would be negative 3 or equals negative 3.5. Divide both sides by 2.4. What's 3.5 divided by 2.4? 1.458. Yes. This is sine, that's cosine. So where's sine of t equals to 0? I can use my unit circle for that one. I can see it. The sine is the second number. I see it here, and I see it here. Can you see it in both places? 0 and pi. So the answer to this one, 0 comma pi. Or 180 if you want to use degrees. I'll use degrees because I don't know where the radian on this one yet. So I'll say 180 degrees. I can always convert that to radian later. What about that one? Cosine of t. So t will be what? The inverse cosine. The inverse cosine of negative 1.45. What do you think? Do I need a calculator for that one? I'll say no solution. What do you mean by no solution? The cosine function always between what? Negative 1 and 1. If the value is outside, this will not have a solution. So guess what? There's my only solution. 0, 180 in degrees. You want it in radian? 0 and what? Pi. That one has no solution. The cosine cannot be more than 1 or less than negative 1, neither the sine. So if you have and if you try your calculator, it's going to give you an error. 1.458 negative. Where's the negative sign here? Where'd you go, negative? Negative, here we go. Inverse cosine. Error. Can't be. Doesn't exist. So there's only these two answers. I wanted to do one with like double the angle, but I know I'm not going to have enough time. I'll just make a simple one. Just one simple one. Maybe I can do it quickly. Solve for x. Cosine 2x equals 1. I just want to solve that one. Just in case you forgot, and let's put this, x between 0 and 2 pi. If you graph this function, cosine 2x, what's your period for cosine 2x? Period is what? 2 pi divided by b. Remember that from before? B is what? 2 here? So the cosine looks like this. That's pi here. That's 2 pi. It repeats itself every pi. They're saying x between 0 and 2 pi, not including that one. So notice there's no equal sign. So the question, where's cosine of 2x equals to 1? I see two solutions. I see it right here, and I see it right here. Because the function repeats itself. Now what happens if it's the same question, but instead of being 1, we said cosine 2x equals, I don't know, 1/2. Same picture right there. That's right here. That's the 1/2. The amplitude is 1 here, but I want where the cosine equals to 1/2. So I'm looking for this x value, this x value, this x value, this x value. So where's the cosine equals 1/2? Cosine equals 1/2. We say, well, 2x, because that's what this one is, equals the inverse cosine of 1/2. 0.5 second cosine, it says 60 degrees. 2x equals 60 degrees. We'll convert that to radian later. That means x equals what? 30 degrees. That's this one. Remember, this is the 45 here. That's the 30. This is the 90. What's that one is going to be? What's that value? That distance from here to there should be what? 30 more than 90, which is what? 120. The next one here is you take the first one, add to it 180, because it repeats itself. So what's the 30 add to it? 180. 210. And the last one is going to be what? 180 plus 120, because it repeats itself. 180, 280, 300. So now you want to convert these to radian. You do the same thing we did before. 30 times pi. I know there's a button on this, I just don't know it. Oh. 30 times pi divided by 180. 0.524. 120 times pi divided by 180. 2.094. 210 times pi divided by 180. 3.665. And 300 times pi divided by 180 equals 5.236 radian. These are the 4 answers. Will be 4 instead of 2. If it was 3x, would be 6 of them. If it was 4x, would be 8 of them. And I'll stop here.
Can I get those notes?
Well,